Welcome to the MIT App Inventor Global Education Summit. Welcome to those of you here in the Stata Center at MIT, home of the Computer Science and Artificial Intelligence Lab. And welcome to those of you around the world who are watching online. We're glad you all can join us. My name is Andrew Whitacre. I'll be helping out, kind of getting things started each morning. And I'm about to hand things over to App Inventor co-founder Hal Abelson, who'll be here remotely. But just for myself, I want to say what a joy it is to have you all here. Where today, tomorrow, and Wednesday, you're going to hear from and meet with some of the pioneers of computing education, but also with the people building its future. Like those of you you'll see in the Global Appathon Showcase and youth paper presentations, and even through the MIT Hacking Medicine Hackathon. Mixed in will be sessions, workshops, and demos for everybody. And when I say everybody, I don't just mean people that are watching. We're stoked to have satellite workshops happening in Japan, Hong Kong, Romania, and India. Japan's is underway right now. India's, which is hosted by Quest Alliance, just finished an hour ago. Hong Kong's is dedicated, is a dedicated one for educators. It happens tomorrow with registration, I think, still open at hkinnovationnode.mit.edu. And for Romania, well, we're thrilled to have one of their representatives here for a panel tomorrow morning. So let's get started in earnest. Welcome to the screen Professor Hal Abelson. Hal's work at MIT has focused on making computing more accessible. It's amazing. All right, we've got infinite Hal. There we go. His focus on making computing more accessible for everyone. He is a co-founder of MIT App Inventor, the platform that we love, that helps people build apps even as they're getting started with computing. He's also helped launch major open knowledge efforts, including Creative Commons, Public Knowledge, and the Free Software Foundation. So please welcome Hal Abelson.
Okay, thank you for the introduction, and welcome. I'm so glad that you're joining our summit. As you just heard, this really is meant to be a worldwide activity, because this idea of computing becoming more expensive is really something that's about the world, and I think you all know that. And you'll be hearing today about App Inventor, you'll be hearing about what we'll be doing at MIT and other things. But mainly, I hope for today and tomorrow and the next 2 days, you have a chance to learn from each other and to be inspired by what everyone is doing, because this meeting is really about you, right? And it's about two groups especially. First of all, the teachers. Can people who are teachers here raise your hand? I can see. Okay, and secondly, about students. Who here is a student? Great, thank you. So this meeting is really, really about you. So we'll go on and hear about App Inventor and hear about all the things that are happening. But first this morning, I would like to introduce Gerald Sussman. Is Jerry here?
Right on, right here.
Okay. So Jerry and I have been colleagues since the 70s. Jerry's actually been at MIT since, God, I think 1963. 1964. And he's really been involved in how computing and using computers is a way of expressing knowledge. Even goes back to his first, he's been a member of the MIT Artificial Intelligence Laboratory for what's it now, over 60 years. And it's really been about how you think about computing as a way of expressing knowledge. So I want to introduce Jerry. I'll talk a little bit later about App Inventor, but first I'd like to introduce Jerry to just talk about this idea of why computing and working with computers can be a very powerful way of expressing what's going on, not only in building programs, but in doing engineering. Jerry also creates watches, telescopes, all kinds of things involved in how you use knowledge in science and engineering. Jerry's one of the most distinguished professors at MIT, and that's what he's been doing for his whole career. He's been my colleague since, I think, about 1973. And we'll talk about that later. But first, let me just turn this over to Jerry to talk about this whole idea of what it's like to have power and express knowledge. Anyway, so thanks a lot, Jerry. Welcome.
Hi. I'm been here for a very long time, as Hal says. And right now, I'm going to tell you about why programming is fun. Okay, and that's very important because I'm talking about programming for reasons that have nothing to do with the value of the result. What I'm talking about is how more about what it's like to be a programmer and why that's an important thing, good for ourselves, why we like doing it, and why it's a good thing. So, and unfortunately the date here is wrong, but that's a separate issue. I apologize. Okay, way back when I started working at MIT, that's what computers looked like. That one's not at MIT. That one is at NASA, but it's basically very similar. We had two of those at MIT, IBM 709s or 7094s. That looks like a 7094 actually, but not a 7094 Model 2. And those cost, 15 million bucks, and basically your watch is much more computing than that. It had 32K, 36-bit words, and it ran at 100 kilohertz. On the other hand, it had a hell of a high bandwidth, okay, for running those tapes. So that's what they were like. This is me in 1969 approximately, or 68, at the console of the Artificial Intelligence Laboratories PDP-6. Okay, so I'm going to give you some history about how I got into this stuff. By the way, on the wall here is the commemoration of the fact that this machine basically played in a tournament, a chess tournament. It was written by Richard Greenblatt, wrote a famous program, MATHEX 6, and it actually won against people. And that was the first time a computer had actually played against people. Okay, so that was 1967. And by the way, if you remember dial telephones, the telephone number there was 6765, and people who answered the phone said Fibonacci of 20, because that was the telephone number. Anyway, here's what I really want to tell you. I want to tell you about what it's like to be a programmer. Okay, that in some sense it's an art form. Okay, the people who normally think about programmers as coding, right? It's starting with some spec that some boss gave you, and the boss had some idea what the spec is, and you have to fill it in. That doesn't work. That's just a bad idea. It doesn't make sense because you have no idea what the spec ought to be. The boss doesn't have any idea what the spec ought to be, if you really look at it. Consider something like Microsoft Word. Okay? How would you specify it? What would you say it's supposed to do? Or even just a chess program. It's easy to specify it plays correct chess, but whether or not it plays good chess has nothing to do with a spec. There's no way to do that. So in fact, most of the time what we do is we actually, as I say at the bottom here, we explore the space of possible implementations and decide what kind of specs we could actually achieve, and that's the sort of thing that actually turns into the real spec. The real spec is based on matching up what's possible with what someone might think they want, okay? So don't let a boss tell you what to do. Okay, next, what makes programming different from other kinds of engineering? Specifically, it's abstract engineering. There's no, for example, when we deal electrical circuits, I build electrical circuits and things like that. Electrical engineering type stuff, which I'm a professor of electrical engineering stuff requires dealing with energy and materials. And those things have tolerances. There's error in the values of the components. Okay, that is unavoidable. There's things that have to do with heat and other such problems like that. In programming, we don't have that problem. Programming is entirely limited by the complexity you can deal with in your mind. Okay, and that's why it's a very interesting kind of engineering that's different from the traditional kind of engineering. So we're limited only by, as I say, the powers of our mind, the ability to organize ideas and control complexity. That's, by the way, when I put up slides like this, they're not intended for me to read them. They're not intended for you to actually read them either. They're for me to remind me what I really want to tell you about. Okay, I'm talking to you. I'm not talking to slides. Anyway, what is it really like to be a programmer? This is a really interesting kind of question that most people never actually think about. Okay, and the way I like to think of it is, I'm going to pick a guy whose job it was to program humans to read emotions, a poet. Very famous poet, Edgar Allan Poe. He wrote a famous poem called The Raven, which is probably almost all of you know. Everybody know it? Okay, it's a remarkable poem which has very strong emotional impact. And the question is, what is he doing? He actually wrote an essay explaining this, how he did it. Look, and the very most important thing here is that the work proceeded step by step to its completion with the precision and rigid consequence of a mathematical problem. He basically had to take little parts that had particular emotional impact, paste them together. Sometimes you have to shave a little off here and fit something together here and get some glue and all that sort of stuff, okay, to make it work. It's really like engineering, okay? And in fact, if you're a mathematician, which Hal's a mathematician, okay, if you think about a mathematician, when you make up a theorem, you do the same thing. You're figuring out the big pieces of idea and you're hooking them together to make them work. And sometimes they have to do a lot of tweaking and inventing new ideas and things like that just to make the interfaces between the parts. Okay, so that's the sort of thing that I think everybody should read. This is a famous paper called The Philosophy of Composition. I highly recommend to everybody. Okay, so isn't that what programming really feels like? It's this doing that sort of thing. It's figuring out what you have pieces, how those pieces have to fit together, and how you have to make those pieces fit together. Okay, and how you get the result that you intend, okay, which is, or something like it at least, to the best you can. Now, I'm saying something more like this. Programming feels like being an artist. Okay, all of these particular kinds of arts have the same structure, the structure I just said, okay? Especially even theoretical physics, which I'm most interested in. I teach theoretical physics sometime. And that sort of thing is the same problem. Modern quantum field theory is a bunch of effective theories, and they sort of work. They produce all sorts of strange results. Okay? Some of them don't really fit together very well. That's why we can't get gravity into them. I can give you a lecture on that, but I can't, and that would require a lot of math on a chalkboard. But I'm just trying to explain that that's the kind of feeling that stuff is, okay? So let me tell you about something that happened to me when I was a freshman, okay? That was 1964. I started working at the AI lab by accident. I met Marvin Minsky by accident. I was told that there was a computer by other undergraduates, that there was a computer on the 9th floor of Tech Square that no one was using because it was brand new, okay? And you should go over and play with it. And so I went over there, and there was Greenblatt, the wizardly programmer. He was in charge of it, and he gave me a manual, said play with it. And there was I wrote some code to make actually a neural net that would learn to play tic-tac-toe, believe it or not, okay? That way back then, but I didn't understand what I was doing, but it worked sort of. And one day, while I was playing with this, a bald-headed man showed up, and I decided he was going to throw me out. He was obviously the boss. And he came over and talked to me and said, gee, how'd you like to get paid for doing that sort of thing, after he talked to me for a while? And that was what we call UROP now. There wasn't a UROP program then, Undergraduate Research Opportunities Program. And then he made this wonderful comment. Why'd you make your neural net at random? I said, because I didn't want to have preconceived misconceptions. He said, it has them, but she just don't know what they are. Okay, and that was an insight that I learned a great deal and enjoyed learning. But basically, I hung out with what we called Minsky's hackers, which were the programmers that made everything work on these tiny little machines that do all sorts of stuff. Okay, we make it, and one of the things we used was a Lisp. And Lisp is a great language because it's completely simple. It's easy to implement in any machine at all. I think App Inventor underlying it has a Lisp, right? That's correct.
Yeah.
Okay, it's got to be. Almost every computer language has one underneath it, and nobody would want to say that. Okay. Anyway, this is the basic interpreter for the simplest possible way you could write it. It's called an eval-apply interpreter. And again, you're not supposed to understand what it's doing. That's a different problem. I could teach you that. That's another lecture. Okay. But the fact is, it's made out of two parts called eval and apply. And a val takes an expression and an environment, which it gives you the interpretation of the symbols in the expression, and it produces a procedure and arguments go to apply, which then takes the procedure, applies it to the arguments, making new variables, so that then there are expressions to be evaluated, which is the body of the procedure. Okay? This is the basic idea. Okay, so very interesting. This was a revelation to me when this was shown to me as a freshman by actually, I think, Bill Gosper, one of the famous other hackers. He was a mathematician, and Minsky used to call him the best 17th century mathematician in the world, okay, because he did all that kind of stuff with a series of stuff and things like that. Anyway, that's the central idea, okay? And Hal and I wrote a book about this sort of stuff, okay? And basically, it's a great revelation. The great revelation is that every computer language is built out of this kind of stuff. This is the center of every computer language. It's got an eval-apply interpreter somewhere in it, with the minor exception probably of Prolog, which is built slightly differently because it's got backtracking built in. I'm not going to worry about that. However, that was a revelation when I was a freshman. Another thing that happened when I was a freshman was I took the introductory E&M class, Electricity and Magnetism, from actually Ray Weiss, who won a Nobel Prize a few years ago for LIGO. But anyway, Ray Weiss, we were taught Maxwell's equations, which are probably the most beautiful equations ever produced in physics. Okay, they basically say that magnetic fields are a consequence of moving electric fields. Electric fields are a consequence of moving magnetic fields. Okay, and that's very nice. And guess what? If you do some math, you end up with the wave equation, which says that light is, and radio waves and everything else are a consequence of this. Okay, again, I'm not going to go through the details of this. It's not interesting. But what's interesting is the revelation. The revelation is that electric fields are produced by moving magnetic fields. Magnetic fields are produced by moving electric fields. It's just like the eval-apply interpreter. It happens with the same thing in the same idea. In fact, in ordinary Newtonian mechanics, okay, the reason why something moves is because it has velocity, right? The velocity is produced by the acceleration, a change in velocity is produced by accelerations, which are from knowing where you are. So knowing where you are produces accelerations, like I'm on the Earth, as the gravity pulling me down. That changes my velocity. I'm walking this way only because I can't walk that way or that way. And guess what? That velocity then is updated by the accelerations. The velocities update the position produces the forces. Guess what? We now have this, just like the eval-apply, a two-phase system. Okay, everything goes around the same way, and I think the entire universe works that way. Okay, so there's a sort of the kind of thing that makes me feel good about this is that there's deep philosophical insights you get from being a programmer. Every day when you're a programmer, you're thinking about all sorts of things like this. Okay, what you're thinking about is, for example, what is the meaning of the word Chicago? It appears in a program, for example. It's not clear. Okay, I've had a big fight with a philosopher by Fodor about this, where we almost came to blows. Okay, exactly what the meaning of the word Chicago is not obvious. It's surely not that particular block of land. It's surely not the people in it. It's surely not some abstract word. It's not that it only has seven letters. I believe that's right. Okay, it's a much more complicated question, and philosophers think about that all the time. What does it mean for two things to be identical? Okay, if I got two of these, okay, here's two objects. Are they certainly similar? They look the same. Are they the same one? No. Well, how do I know? Well, the way I can tell is if I open one of them, the other one's not open. It has to do with change. Identity and change are required, are a fundamental idea, and only if programmers have to think about it all the time when they have mutation of data structures, and that's a very fundamental idea. So there's also things like the logical problem of quotation. John knows the morning star is Venus. We know the morning star is the evening star. That does not mean John knows the evening star is Venus. You can't substitute equals for equals in quotations. Oh, that gets real trouble in programming languages and real trouble in programming. Okay, then there are things like here's something that machine learning people have to worry about. If something is, If something is a raven, it is black. You all know that, right? Okay. On the other hand, if something's not black, it is not a raven. That's just a contrapositive. It's true. Unfortunately, one of those, seeing a white coffee cup is not telling you anything that ravens are black. So it's not evidence for the fact that ravens are black. So there's something funny about how logic fits in with other kinds of evidence. And we really don't understand that. There's lots of theory about this stuff, but we don't really understand it very much. And we have this problem all the time when we're dealing with what it means like machine learning and those ideas. Okay? So then there are questions about the things like programming. How much time do I have, by the way? Oh, good. I can talk. I'm talking as fast as I possibly can. I'm from Brooklyn. And yeah, 15, good. When I was a freshman, I had to unlearn the problem I had from Brooklyn, which is that people in my neighborhood had they were Eastern Europeans. They would stand close to each other and talk, poking each other in the belly as they talked, okay, and talking full duplex, which of course is considered somewhat rude outside of Brooklyn. Okay, so I had to learn not to do that. But that's a separate issue. Anyway, there's this idea of what a bug is. Bugs are, as far as I'm concerned, a bug is an opportunity to learn something. It's not something which is you should avoid. In fact, I think it's absolutely essential to make bugs when you're building things. And I'll explain that in a minute. So the idea is that planning requires simplifying to achieve an approximate result. The result of simplification is bugs, but debugging refines the design to be more correct. So there's a whole strategy called problem solving by debugging almost right plans. Okay, and I want to make sure that you understand that this happens all the time in everything you do, including if you're writing poetry, as Mr. Poe. Okay? But I'm going to put this in the context of something else, electrical circuits, just because I think about that too. Okay? So here's, if I'm building a telephone system, telephones, your human voice, the only interesting information is from 300 hertz to 3 kilohertz, basically. Although the vocal cords are around 100 hertz for a man and 125 hertz for a woman or something like that. But your brain doesn't even need that information. What's information is the harmonics of those. Anyway, so you make a filter like this that cuts off at DC because you don't want someone frying the system by putting DC into it, and it cuts off at say 3 kilohertz or 3.5 kilohertz or something to limit the bandwidth in the telephone system because it's a waste of bandwidth for getting intelligible speech. Okay, so you do something that looks like you get something called a system function. You make a filter. Okay. Then, if those of you who know about electrical engineering, you see that you say that that's a discretization of the idea. This is a thing that's going to have several poles and zeros, whatever that means. Again, that's mathematics. Not interesting right now. But the point is, it means that the thing's made out of a product. That is, the system I'm building here is made out of a product of parts, as you can see over here. Okay. Quotients and things like that. I have plans in my mental library. Here's one plan. Which is take series in, parallel out to makes the sum of two system functions gets me a system function. Okay, that's one idea. Another one I have is the product, which gets me this one. And there are many other such plans. And so what I'm going to do is say, supposing I try to implement this plan. Well, here's a way of implementing a single pole, and here's a way of implementing a pole and a zero. Okay, I'm going to multiply them together. Boom. I'm going to make that thing, and it doesn't work. Okay? And the reason it doesn't work is because the assumption, this is taking a good idea, a good plan, and seeing why that it doesn't work even though you've done the right thing. Okay? And the reason why it doesn't work is because this part of the circuit expects it's being connected to something that doesn't suck up any current, and this part of the circuit is sucking up current from the previous one, so it's called a loading bug. I have a name for a bug. Ooh, it's like fence post error is another kind of bug. Okay, which you all know about as programmers. Okay, bugs have names, and if you have the right name for a bug, you have power over it. That's an important thing. Okay, so once I have a loading bug, I can fix that by putting in an amplifier. Okay? I'm just trying to explain that that's a patch I know for that kind of bug. Now that one may have its own bugs that I've built just this thing. Okay, for example, that will not work if I'm trying to put a circuit in a radio transmitter that has to I'm going to take a kilowatt of stuff coming out of the transmitter, and I want to put it through a filter. I can't put an amplifier in the middle. I just smoke the amplifier. Okay, so that's a different thing. Okay, but that's an example. So it's a very simplified example here of an idea. Okay, what I have here is there's plan libraries. They have approximate solutions. Each plan gives a way of causing a stab at the problem. Okay, that the name bugs are associated with the plans. The plans have bugs in them, and the names for each one. There's a little list of all the bugs that could happen. And you should know those when you're building things. That's how you become an expert. Okay, and then there are lots of examples, like for example, reader-writer bugs, ground shorts in the electrical world. There are name patches for each one. Okay, for example. Okay, which is the ways you fix them, and that's how you become an expert. Okay, and so yes, but I'm going to say something else. Sometimes the bugs are ugly. Okay, here's an example of Python, which I'm not going to say anything positive about. Okay, it's an example of it's a very popular piece of crap, and when you look at it, there's ideas like this which are which show how inconsistent it is. What's a squiggly bracket? Well, it's not, or brace they call it, I suppose, in English. Okay, it's not clear. Of course, C++ is even worse. Okay, but even worse, here's an example of a completely crazy idea. You know, look, here's a list. Okay, and I'm going to say for the 0th element, the 1st element, the rest of the list, and so on. It all works. If I try to make it into a tuple, I get the wrong answer by using the same plan. Guess why? Definition of tuple is when there's a comma in it. This is the kind of nutty design that somebody would build. And I personally have lost several hours of my life chasing down nonsense like this, which never occurs in, say, a Lisp, it can't happen. Okay? And I hope in App Inventor, things like nonsense like this doesn't happen either. Okay? Yeah, let me tell you, that's one thing. Now, I'll show you another part of it. There's a pleasure of discovery. How much time again? Good. Okay, I'm going to be on time. So here we go. So I hung out with Caltech. I was learning about general relativity. And a friend of mine from Hewlett-Packard showed up. He's a chip designer. And we decided we were going to think about derivatives of functions. Like the derivative of the function that cubes is a new function, which then, when applied to 2, gives you 12, of course. 3, right? That's the derivative of x cubed is 3x squared. Okay. So we discovered at the time, personally, although many people had discovered it before, forward mode automatic differentiation. Now, given something like that, for those, again, a scheme, sorry, there's a Lisp type of language, this just makes it a nice example of how you can use it to find out where cosine and sine cross over. But in any case, and there's technical details of how it works, it runs on the chain rule, not very interesting. But here's the important thing, okay? Because we're using scheme, I can redefine all the primitive arithmetic operations to work with our differential objects. So we had a hack attack. A hack attack means we stayed up all night because it was so much fun working on this. Okay, and by the morning we had a scheme system do automatic differentiation with both unary and n-ary functions. Okay. Of course, that's with a preliminary plan with lots of bugs. Hal helped us figure out some bugs sometime later, and various other people like Siskin, Perlmutter, and Radul, one of my students, helped debug the idea for derivatives of higher order functions. I'm not going to explain that stuff. Okay, but here's the important thing. Besides being that it was fun to stay up all night to do this and learn something, which we learned, okay, the important thing here is that we built a system based on this because it was pretty easy, and we have all of our arithmetic generically extended to operators, vectors, covectors, matrices, manifolds, vector fields, form fields, and tensor fields, functions and operators, and so on. So we could actually play with general relativity within a few weeks. Okay, just doing this, figuring it out right. Okay. In fact, we have software that does things like Lie transforms and all that sort of stuff. I'm not going to explain any of this stuff. Okay. But you see, here's the important thing. The important thing is that Dan and I came up with an idea we can make differential objects which, when passed through a function, automatically implemented the chain rule. That felt good. You see, it was really a revelation that it worked. Okay, it wasn't obvious that this was true. Okay, and when the idea was coupled with the technique of generically extending the primitive operators, I knew there was a fruitful plan for the system. The fun was the discovery of the plan and the subsequent multi-year elaboration of the system with Hal and Jack Wisdom. Okay, and so we came up with a couple of books with Jack Wisdom. Here's one on classical mechanics, which is very advanced classical mechanics. Even the graduate student would take, which has things like, besides Hamiltonians, Lagrangians, and things like that, canonical perturbation theory, all the hairiest stuff you can think of. Okay, and then the functional differential geometry, where this is actually one of the programs drawing the geodesic of light beams, okay, going around two mass concentrations, probably black holes. Okay, I wrote the program that did this, okay, and that's why it's on the cover. And it was written basically by my program writing it, okay, from Einstein's field equations. Okay. Now the important thing is that, of course, I laid out the initial conditions, so we got a lambda because it's lambda calculus, which is the foundation of almost all computer programming languages. Okay. In fact, you see lambda everywhere whenever we deal with this stuff. Okay. Lambda calculus by Alonzo Church. So of course, this is another kind of pleasure, the pleasure of taking something you think of as very hard and making it rather easy because you've written programs. Hal wrote a great book called Turtle Geometry with Andy DeSessa. I hope you have seen it, which does a lot of this in discrete differential geometry, okay, way back in the past. Okay, so that's just the sort of thing there. And I don't care about this much. This is just showing you that sort of detail as for teaching. But here's the important summary. I'm about to summarize because I only had a few minutes left. Okay, one of them is the introduction programming produces intellectual pleasures. The pleasure of discovery of analogies, okay, which you see there. The pleasure of philosophical contemplation. There are eternal problems that every programmer must encounter. There's the pleasure of debugging, which there's a hunt. Okay? The pleasure of discovery of good ideas, such as higher order functions and extensible generic procedures, simplifies the idea of automatic differentiation, things that people took years to do in things like C, for example. Okay? And the pleasure of clarity. You can take a difficult subject like general relativity, and we can make it much clearer and easier to understand. Okay? That's the sort of thing. Okay? So this is the reason why I consider programming to be fun and independent of its value, the value of the results. The value is not just the value of the resulting artifact that someone might sell or use for some purpose. The real value is the change in the mind of the programmer, how the programmer learns to think better because they're programming. I believe that programming, as Hal and I wrote in our book, is a method of expression of ideas. It's a new way of expressing ideas. It's expressing not just what is, but also how to. That's very different from, if you look at traditional mathematics, writing an algorithm is not so easy. Okay? Writing a complicated system with hundreds of algorithms hooked together is impossible. Okay? But writing a program, you can make a combination of things that is much easier. That's a recipe for doing something really complicated, like computing the consequences of Einstein's field equations. That's the sort of thing that is a very different kind of thing. So here's the conclusion, and here's one of my heroes, Marvin Minsky, wrote this before most of you were born. Okay, a computer is like a violin. You can imagine a novice trying first a phonograph. You know what a phonograph is? Okay, maybe before your time too. And then a violin. The latter, he says, sounds terrible. That's the argument we heard from our humanists and most of our computer scientists. Computer programs are good, they serve for particular purposes, but they aren't flexible. Neither is a violin or a typewriter. Those days, typewriters were there, until you learn how to use it. This is from a paper by Minsky, Why Programming is a Good Medium for Expressing Poorly Understood and Sloppily Formulated Ideas. That's my conclusion, okay? And one more thing, I just want to say that it's also important for software to be free Libre. Okay, I'm the founding director of the Free Software Foundation right now. Okay, and so Hal was a director also of the Free Software. He's not now. Okay, and we produced, like for example, Linux and stuff like that. We produced an entire system called GNU, and we are now currently, for example, working on making cell phones have free software in them. Okay, that's much harder at this point, but be a member of the Free Software Foundation. I've been from the beginning because I believe. I'm not interested in competing with people for goodies. I'm interested in making sure we all cooperate. Cooperation is far more important than competition. Okay, that's it for me. Anybody have any questions? I'm perfectly happy to answer them. I have to drink a lot of water, sorry. Do I have time for answering questions?
Yeah, if we have any. Any questions? We have mics on the sides if you...
If anybody wants to attack, I love it. I promise to have fun with you. Mm-hmm. Okay, a different crowd from the one I normally deal with. If this was MIT undergraduates, I'll tell you, I'd be already ducking various very smart questions and very smart. I'd have to produce those. I'm saying I have to go away and think about that and talk to you tomorrow. Yes, sir. Is there microphones here for him, or is that? Yeah, because other people won't hear you. Okay, there it is. Yeah. When someone asks you one, you want other people to hear them.
Hi. Thank you. This was very interesting idea. So I was mainly interested in the last slide where you put up the free software approach. How, let's say, young students who have just experienced, with programming, how they can participate in the work in the free software website that you just.
Oh, how they what?
How they can participate in that? I mean.
How people do it all the time. People contribute. There's huge amounts of volunteer effort for free software. And you should basically contact the fsf.org, or GNU.org, which is the GNU project, and there's a gazillion of things we want done. Okay? And also, it's been around but we started this probably in 1983 or something, awesome. That project. Okay.
Good one. Thank you.
Yes. We got her. Yes.
Hello. Yeah, thank you, Professor Sussman. I think your speech makes the programming very fun, interesting, and inspiring. I have a question really related to the current artificial intelligence era. We know that a lot of grad students with computer science degree have hard time finding jobs. So what's your insight for why?
Well, first of all, I haven't seen that happening.
Okay.
The graduate students I've seen are doing fine, but it will be true in the future. There's no question. You're right.
Right. Okay? Yeah. So I would like to really get your insights on why programming is still really valuable, even in the artificial intelligence era.
Well, I want to say this. That's why I talked about fun. Okay. The fact that a computer can play better chess than me doesn't mean it's not fun to play chess. Okay. And I think the most important thing is to consider. Well, yes, these machines are tools. It may be the tools will be able to do things we can't do. Okay? I'm not so sure that there's any reason why people should play tennis. After all, a machine could, in principle, do that. And surely we have big things that can excavate large pieces of land in no time at all. But guess what? There are people who do gardening too. Okay? So I think the critical thing is what we should do for ourselves, not so much what we do. I'm not worried about the practical value of it. In the long run, yes, indeed, it may very well be the case that there's no practical value for people doing any work at all. It may be true. I'm not sure that matters or not. What really matters is that people better have things that they want to do that's fun.
Okay, thank you so much.
Okay.
Thank you so much for your great presentation. I have a follow-up question based on that. We could say violin is fun. We want people to learn violin, but we probably don't want everyone to major in violin, spend 4 years become a violinist, right? And Then my question to you is, when you think about the future of computer science education, do you see it more as something, it's like a tool, like a violin, everyone learn a bit of it, or some people decided to go make it their focus, their major, but maybe you have less people who kind of spend their 4 years concentrating on that, or that's going to continue to be the case where a lot of people will be studying?
I don't know is the right answer. But I think that the one thing we realize is that there have been lots of times in history where things have gone this way. Okay? For example, there's math departments. And there are lots of people who study the abstract math, which is basically an art form for producing beautiful structures. Okay? They're not going to stop doing that just because something may help them do it more efficiently. Right? And it's not like math departments have run out of people. Okay? Okay, let me give this to the next person. Okay? I will turn this off.
Yeah, I just want to say I love how everything you just presented is, yeah, we can. Okay. Thank you. So just that everything you just presented is embedded in what became MIT App Inventor. I think that's wonderful that, what needed a lot of theory in mathematics and electrical engineering and all is something that people like Hal Abelson, Mark Friedman, and others, and millions of other contributors were able to build into MIT App Inventor. And that was just, 15 years ago. So thanks again, Jerry. So for our first invited talk, I'd like to welcome up my colleague, Evan Patton, who's lead software engineer for MIT App Inventor. And he's going to catch us up on what's new with the platform. So, Evan.
Thank you, Andrew. Yes, so every time we do one of these summits, I get the opportunity to talk about App Inventor and what we're doing that's new. I'm coming up on 10 years at App Inventor in 2 weeks' time, so I'm very excited to be here and sharing some of the great work that our team is doing. I just want to recap, though. We have a bunch of, oh, this is still off. Yeah, I turned it off. Let's not turn it back on. Hold on. Vibrating. Okay, there it goes. We're good. Yeah, so we have a wonderful program for you today. Andrew kind of already gave you the brief overview. We have a whole bunch of talks in this room over the next 3 days. In the afternoon sessions, you'll have workshops and concurrently the hackathon, which we're really excited about. And then tomorrow, they're going to have a whole bunch of posters and demos, many of which will be relevant, as you'll see. Today, we're looking at over 150 of you coming over the next 3 days, and you're coming from 15 different countries. So especially for those of you coming from Southeast Asia, props to you. That is a long flight. I know, I've been there. So thank you all for coming, and thank you for attending. And of course, thank you all of you who are watching online as well and at our satellite locations. So what's new in App Inventor? Well, first, a little bit of news. Last week, we hit 30 million users of App Inventor all time. So thank you very much. We're so excited. App Inventor started 15 years ago, or rather at MIT it was at 15 years ago. It started at Google a little bit earlier than that. But since it came to MIT, we've had 30 million people use the platform. That's over 2 million a year. In fact, 2.5 million of those have just been the last 6 months. So we're growing at an accelerated rate, and likely we'll be hitting 5 million users a year by the end of this year, which will be fantastic. We are also moving to a new server infrastructure. So for those of you who have been using App Inventor since November, you're probably already on the new infrastructure. This allows you to build bigger apps. So previously, you were limited to only 30 megabytes. You can now increase your apps to 50 megabytes and even more, allowing you more media, more, whether that's audio, video, images. So you have a great opportunity to build more with App Inventor. We also released a feature where you can save your apps to your phone in the companion app. So if you don't have the ability to build your application for whatever reason, for example, like on Apple, you have to sign a licensing agreement. And if you aren't able to do that, then you can still save your application. And so we're really excited to be able to offer that as well. But now I want to share some of the upcoming features, and you'll get to, as I mentioned, see a bunch of demos of these over the next few days. And please find the developers in the room. I'll call them out. Some of them are here, some of them will be here tomorrow, so you can talk to them about what they're doing. So the first thing is, who here has played Pokemon Go? Oh, I was actually surprised. I figured there'd be a couple more hands than that. Yeah, during COVID, it was a great way to get outside. But yeah, so we have been working on bringing augmented reality to App Inventor. So you can now build applications that contain augmented reality programs. You can put content into the world, augment the physical world. This can be stored in components like CloudDB, so you can share it with other people using your application. And we're hoping that this will enable a whole new series of applications around data science where you can start to think about, what's the volume of that speaker over there? Or, oh, I have this plant, is it thirsty? And that you can actually start to measure the world and present new information digitally on top of the physical realm. That'll be demoed tomorrow, by the way. The other thing that we've been really excited about is 10% of our users every year are using App Inventor on a mobile device to build an app for their mobile device. Now, App Inventor's UI, as many of you in this room will know, is really designed to be used on a laptop. It is not designed to be used in a very small form factor. And so through the Google Summer of Code program, we had a student build a mobile version of App Inventor that you can use on your phone to build an app just like you would use App Inventor to do. And it's designed to work in that small form factor environment. The buttons are bigger, so they're easier to tap, and things slide in and out of the screen to give you access while giving you also an overview of your program. So here we can see actually an entire video of someone building Hello Purr, the starter application, from start to finish, just on a mobile device. And so in places where people don't have access to multiple devices, maybe they only have a single phone for their entire family, they still have an opportunity to code and experience the joy that Professor Sussman was talking about. Now, the last thing we're really excited to announce, and that will be coming for this coming school year, is the ability to test on the web. So typically in a classroom environment, you have to build your application on a laptop or a Chromebook, and then you run your application on your mobile device or a tablet. And many schools these days are starting to ban the use of mobile devices in classrooms. And so in order to enable testing, you can open App Inventor, say, test my project on the web, and you'll get a pop-up window that emulates App Inventor just like it would on your phone, and you can try out your application that way. And to facilitate the adoption of this in classrooms, we've built a tool where you can drag all of your curriculum materials, all the AIA files, into this little website, and it gives you a breakdown and a report of how far along we are in terms of being able to support your teaching materials. And this is for one of our curriculum, this is Future Makers. So Tanya, it's good to see you. So Future Makers, we're almost 100%. So we're really excited to be able to say that we can take something like Future Makers and make it work entirely without a mobile device so that kids who maybe don't have access to a mobile device can still take advantage of this wonderful program. And if you are a teacher and you'd like to learn more about this, please come see me afterwards. We're happy to hook you up so that you can get this report as well. But wait, there's more. So we have a very exciting program to talk to you about, and this is our App Inventor Innovation Lab. So we've been working on this program, developing this program for quite a while, and the idea behind this is really thinking about the next generation. What does App Inventor look like in the age of AI? Now, in 2009, when Hal and Mark started App Inventor at Google, the iPhone was just 2 years old. And the production version of App Inventor that you all use didn't come to MIT until 2011, when the iPhone was 4 years old. And now we're kind of 6-ish years into the age of ChatGPT and other generative AI tools. So what does the idea of App Inventor as applied to mobile now look like applied to AI? And of course, as one of the previous questioners asked, how does this kind of reflect on the workforce? What do you do if people might be losing their jobs to AI or something like that? So we want to build programs to enable upskilling the workforce and providing new opportunities in light of all of these changing landscapes of technology, just like App Inventor did with the mobile landscape 15 years ago. It's built around 4 pillars. The first is apps for action. Now, Hal didn't speak to this in his earlier comments, but App Inventor is really built around his idea of computational action. Right? That's not just sufficient to build something, but you build something with a purpose because you want to do something, you want to help somebody, or because you get enjoyment from it, right? You want to do something good in the world. And so the idea here is that we are enabling new programs to try to encourage more applications to help the world. The second pillar is based on entrepreneurship, right? We now are in a world where you can build new things quickly, but there's still a lot of social constructs around that, right? Like, how do you take the thing you built and actually turn it into something where you can earn a living? How can you use it to build a business? Right? Like, those are additional skills that you can't just get from asking ChatGPT or Claude or something like that. Right? There's more human elements. You need to be able to interact with people at a different way, a different level. And then kind of a step beyond that is innovation. How do we innovate with this technology? And there's kind of an open question. We're still trying to figure that out, right? Lots of people are building companies on AI. And we're still trying to learn, just like when the internet came out, we tried to learn what companies worked, what companies didn't work. A lot of companies ended up going bust because they didn't really transition well. Some of us are old enough to remember the dot-com burst, but many of you, may not have even been born. But it was an interesting transition time, and we learned a lot from that. And then lastly, we are reviving our expert trainers program. So for those of you who are teachers, you may have learned about this program previously. The idea behind it is that it gave you an opportunity to learn App Inventor in depth, and then go and become a teacher of other teachers in order to help promote using App Inventor for things like computational action. And now we're hoping to bring back certificate programs so that you can go out and disseminate App Inventor to the world. So if you're interested in any of this, I definitely would encourage you to reach out to Marisol Diaz. You'll see her kind of moving about throughout the day. She has been the one who's probably been emailing you with lots of different things, especially those of you who are presenting. But you can also reach out at App Inventor collaboration at mit.edu. And we'll have more details on our website once the programs are finalized. So with that, thank you very much, and I will take questions. Actually, Susan. Is Susan in the room? Oh, there you are, in the back. So Susan's been working on the mobile UI as well. So if you're interested in mobile UI stuff, she's going to be demoing that tomorrow. Forgot to mention that on that slide, sorry. Yes, do you mind going to the mic?
So earlier you were talking about augmented reality coming to App Inventor, and you kind of relate that to Pokemon Go. So would you be able to save like 3D models in space based on location?
Yes.
Things like that?
Yes, absolutely, yeah. So you can do things either based on lat long and altitude, or you can do sort of spatial based on image markers. So for example, and I think what Cindy will demo tomorrow is on the 3rd floor of this building, there's a big nerd crossing sign, which is one of the many hacks that students have done at MIT over the years. And if you point your camera at that, it'll create all sorts of like balls and chickens and things that you can put into space and then save them. But yeah, we're hoping to see geocaching and other types of applications come out of this because you can tie it to latitude and longitude as well. And, Robert here has been helping develop some of the curriculum around that, so I'm sure he'd be happy to share some of his thoughts on that as well.
Yeah, and would you also be able to connect like AI to that? Because in the chicken crossing example, you were referring to like, you could scan a plant and you could start like, on the screen, you would start referring to details about the plant.
Yes, you can. So one of the projects that Cindy, who will be demoing this tomorrow, is working on is actually being able to take a picture of something and using AI, turn it into a 3-dimensional object that you can then manipulate So you could say take a picture of a toy car and then make it into a virtual car that you could then drive around and things like that using AI. And then of course we have our existing AI components like the chatbot that you can use to interact with things like ChatGPT and give it a personality, for example. Thanks. Any other questions? Okay. Well, if you have any questions, please feel free to come find me afterwards, and we're happy to help answer those. Thank you.
Yep. All right, so next up we have Hisako Nomoto, who recently finished her master's as a Fulbright scholar, at the Harvard Graduate School of Education, where she stayed on as a researcher at the Child Center AI Lab.
She's on lab 3.
Hi.
Almost there.
Okay. Can you guys hear me? Good. Great. Thank you.
Get this to full screen.
Okay. It's like a Google Slack.
Can you go full screen on it?
Yeah. How can I do this? Okay. Is it on the screen? I think. Oh, oh my, oh my screen. You see it? What should I do? Can you give a little bit second? Sorry. Yeah. I wanted to do the presenter view. No.
You need to switch.
Yeah, I'll try. Oof. Okay. Sorry for a second. Yeah, I prepared a really beautiful script, so maybe I'm gonna a little bit mess up, but like, let me kind of start it. Hi everyone, my name is Hisako Nomoto. I just graduated from Harvard Graduate School of Education. I'm working for like a child center AI lab at Harvard right now, and today I really wanted to talk about. I'm really curious about how the early childhood education cross AI right now. So a little bit about myself. My name is Hisako. I was born and raised in Japan. I heard some folks are from Japan. Oh, hi, konnichiwa. It must be a long flight, but welcome. Welcome to Cambridge and welcome to MIT. Like a little bit about myself, like I was born and raised in Japan. I learned English by singing Disney Christmas song when I was a baby. And also I love Titanic. And then I watch a lot of like entertainment contents. And back in college, I studied about early childhood education, especially for second language acquisition. And I found myself, it's really like internal motivation is really impacted by the family engagement. So since then, I'm really, really committed to like education. And after graduate, I joined Google Japan, and I worked there for more than 6 years. And back then, I worked for Google for Education, YouTube Kids partnership, and eventually I was in Gemini Education for go-to-market. So I kind of launched so many Gemini AI training contents for the first thing in Japan. And eventually I joined Hugsy because I really wanted to thinking about and research for what AI gonna give a good impact, but also what's the risks for the kids and the family. So there are like many questions about AI out of school and in school, like right now. Let's say like how AI is rewiring childhood, or there are so many things about the New York Times says as schools embrace AI tools, skepticism raise concerns. So there are some schools thinks about like the school should prohibit the AI or like ban AI. But there are some schools is always like it really encourage using AI for tools. So they're like still there's no like right or wrong answer yet. But there are like so many schools are really struggling and also like thinking about so many questions around AI. And I also dedicated so many the contents or also like app developments around AI and education. But like one thing I really couldn't find out from the inside of the tech is how those like AI tools, how those technology tools can affect for the kids, especially like or the family engagement. So that's kind of the reason why I quit the big tech, and then I joined Harvard to really dig dive into these research questions. So these like three like researches that I'm like working on right now. Those like first two is like my own project, and the third one is like the research that I'm like working for Harvard right now. So let me walk you through like the first one. First one is irori. Maybe like Japanese folks know about the meaning of the irori, but irori means like a hearth of the house. And like it's like a really traditional old house in Japan. There's like irori, and there's no tech. There's like only space that the older families and the children were engaged. So that's kind of the project that I named for that. But I kind of like a reason why I wanted to tell you guys like why I really interested about education in early childhood. So there is like a PISA 2024 research shows that the students' life satisfaction and meaning of life emphasizes the significance of the relationship between children and their parents, the bondings and engagement. So it's not only like the one element that really huge impacts to this like life satisfaction rate, but it shows like it's like huge, one of the huge like reasons still. But when it comes to, let's say, Japan and also like US or like every other market, there are like so many like dual house income householders right now. Let's say in Japan is 70%, more than 70% of the householders are dual income. And most of the families and the parents are really struggling about how to manage the parenting and also during their life. And one of my, like during my research, I found like some like interviews that so many parents are kind of complain about, like she's my own child, like my daughter is my own child, yet the means to understand her are so limited. And I kind of like interviewed some of the teachers at the preschool, and like every day they have a documentation about each kids at the end of the day. But there are like so many like really too general information, let's say how long they sleep, what they eat, but there is no information about their like child development or behavior issues. But on the other hand, the teachers also really burdensome about documentation. That's like the top 3 reasons that they kind of like quit their job. So my research is about, the North Star is how can every parent and also caregivers make decisions not from their own biases, but from their child's real interest. And what we are kind of like, doing on my research is right now to help the documenting for each kids by only the 30 seconds audio recordings, and that's it. So right now it takes like a 3 or 5 minutes for like documenting for each kids. But how can we save those times for only like audio recordings and automatically generate the early childhood development? So that's kind of the researches that I'm like working on right now, and we are kind of like piloting some of the schools right now. But since today's like app development inventor like summit, I kind of like walk you through what's the like a design back behind. So like the first one is like teachers record short audio recordings. So it's only like 30 seconds, but like say, okay, Hisako built the Lego, but she broke it, and then she started crying, but suddenly she could do it by myself. So that's kind of like that. It's like a really simple one. But like after that, we kind of like our AI algorithm analyzes based on the CDC milestones or those US-based child developmental theory. And then we kind of like automatically analyze and show the overview of their behavior issues and what they can do and suggested some like actions that they can do at home. So that's kind of like the design back behind. But what we are really thinking about is not using AI, it's just replacing the human beings. It's more about how to design AI for engaging the fostering the relationship between the human to human, or the children to parents, or the teachers to parents, and the teachers to children. So that's like a whole concept of what my whole research. But the second one is also related to that. The second project is about the storytelling. It's about parent-child interaction for AI-generated storybook. So before that, since I brought it today, but I also published my picture book 5 years ago because I was in the tech side like all day, and I really, really wanted to do some like tangible experiences. And I really found out how the storybook itself is so much powerful, and like the children are really, really wanted to read it. But the parents are kind of like really tired of like reading it every day. But I found out those like a core time is a really rich time for like a family engagement. So my research overview is rethinking AI's role in parent-child interaction for better parent agency and parent-child bonding, from instructor to or meditator to reflective companion. So like long story short, like this is like the research system behind that. What we are using AI is kind of just using only for pre and post reading the storybook at that time. So pre-training is the parents and the child core kind of like giving a prompt about what they happened on that day. So it's going to be like the children is going to be super talkative because they're wanting to kind of create their own story by talking about what happened on a day. But the parents also really helpful because even ask, okay, what happened today? But like the children will never talk about it, right? But this like AI-generated storybook kind of really helped them to talk about what really happened to just like making like their own storybook. And during the storybook, they just like recorded. We wanted to measure like the tone of the voices and how they're gonna match. And synchronization could be one of the measurement point for measure the family engagement. And the past training is just like showing them how they're gonna synchronize it and what they can do for the next time. So we kind of like doing this research for like some of the few parents, and they really love that. I'm kind of really surprised because like AI kind of really skeptical, but this is like not during the storytelling time. It's more like a pre and post storytelling time, so it really helps them a lot to really understand about what is really happening for children, and it's also like a really fun time to just like reading about their own children's storybook. And the last one is like AI toy agents and young children. So since I'm like working for Harvard Child Center AI Lab, the Professor Insu is leading this AI lab. And what they're like working on is how do children learn through social interaction and conversation, and how might AI technologies alter these forms of learnings. And we are like working on the AI toy research right now. And the border landscape is there's so many AI toys are kind of launching right now. Have you ever used AI toys in your life? Have you ever like experienced this before? Maybe no one yet? Maybe. But there are like some countries, they kind of like having so many AI toys. They kind of like a conversational AI toy with younger kids, let's say 3 to 8 years old. But there's so many skepticism, and also they have so many excitements, but there is no evidence, especially like a good evidence for how they utilize this AI toy. So what we propose right now is to condition between subject randomized control trial study in the natural settings. So we kind of compare with the AI toy versus like a usual toy, and how the children is going to behave that, and how those AI toys could help them to, let's say, the language acquisition, or maybe like emotional like acquisition. So those kind of like academic and emotional outcome, how those AI toys going to affect that or not affect in a good way or a bad way. So we kind of like just started now, and we're still on a research process, but it would be great to kind of like share with you guys in the future. So that's kind of like a 3 like researches like working on. I hope it's gonna be like a little bit interesting about you guys. But those 3 like researches, and after like so many like researches references, I found evidence-based design principles for child AI for 3 principles. 1 is extend and don't replace. This is like a word from my professor in SU. But AI should amplify human agency and not substitute the parent, teacher, or peer. So design for co-use, not solo use. And this is also my core research questions. And the second one is transparency by design is pretty important. So what this means is children must be able to identify they are interacting with AI. So there's another research says the younger they are more difficult to differentiate or what's the resources from. So they cannot distinguish the resources that this information is from AI or the human beings. So it's really, really important to transparency by design to show them this is information and that you are interacting with AI when you kind of like design any apps for kids and AI. And the last but not least, the third one is learning first interactions. So effective edtech must be active, engaged, meaningful, and socially interactive. So AI toys should be evaluated against these 4 criteria, and not only AI toys, but any products and any apps that you guys created in the future as well. So I'll stop here, but thanks for listening, and I'm more than happy to talk about those like AI toys or like any child-centered AI design frameworks. So if you have any questions, please let me know. Thank you. Do you have any questions or comments? Yeah, please.
So I really enjoyed your talk. On the second to last slide, you mentioned that one of the principles should be extend, don't replace. But I think, as we all know, it's very difficult for a parent to like give a child something that they really love and take it back and not just leave it with them. We see this with like iPads, obviously, and other toys. So what suggestions do you have for like designing for co-use but making it easier to take back?
That's a really good question, and that's like still I'm like doing for that. But even when I work for like YouTube, it's really important to set the time restrictions. So even us as like interactive AI tool or like do like the virtual reality or like any technology, it's really important to set the limitations for them. So there's like a role. So any like just play in the park or doing the AI and just read the storybook. They have like a really different like the roles and for interacting with family and kids. So my answer is it's really important to set the time, maybe inside the technology system, to show them, okay, now it's like a time up. And then you have to like move on to like another like activities or such as that. So it's really difficult to detach it, to be honest. But it's really important to teach the kids that what is each like the activities are like a role for the child development, which is still really difficult. But from the design perspective, it's really important to set the limitations for that to really simplify what's the role for this. Thank you.
I'm curious if you could speak. Oh, go ahead.
No, go ahead. You started, go ahead. So one of the things that I kind of toy with, especially with young children, is anthropomorphization is important for childhood development. I know it's important for my 4-year-old to believe his toys are real, to develop social interactions. But I also know that we develop mental models with technology when they anthropomorphize with young students too much. So I'm wondering your take on what is the balance of anthropomorphizing with technology at a young age?
You mean like the more like a mental development perspective? or-
Especially, essentially making applications and technologies that build trust by appearing humanistic and agentic.
I don't have the answer yet.
Yeah, I don't either. That's why I wanted to ask
Yeah.
you.
Because, let me say, it's really difficult because it's better for like younger kids, let's say like 4 years old, like AI gonna impact you a lot. So like another research that I'm working on is psychophancy. What is psychophancy is AI's feature is really giving you really positive answers, right? So every day, like AI will never bored you in any questions, and then giving you a positive feedback no matter what the really wrong questions. So, sorry, I don't have the answer yet.
No, I don't
but
expect you to either. We can chat a little later.
Yeah,
but it's something that's on my mind too. So.
But the point is, there's like a really, maybe like a good impact, but also like the harm that those psychophancy features overall, let's say the Claude, Gemini, ChatGPT, overall like the old AI has a psychophancy features yet right now. And those psychophancy features gonna give a huge impact on moral development or like a mental development for kids because they will not like hear you, but like they will hear like AI. Like the trust, the sequence of the trust is kind of really changing right now. So it's a little bit different topic might be, but like those topics are also like happening around this, the tech versus like really non-tech, like a parenting, like right now. So yeah, it would be great to talk with you. I have like so many thoughts about that.
Thank you.
Thank you.
Actually, my question is somewhat related because I've read papers where people have tried talking to the AI models as if they were children, but they're actually adults, and then seeing how the models maybe guide the children down paths that maybe the parents wouldn't agree with. So I'm curious, are you building your own models for these types of AI toys? I know you showed OpenAI partnering with Mattel. But what other guardrails are people putting into place to make sure that, say, the toy isn't encouraging the child, like, oh, well, your parents, you shouldn't really trust them, right? Like, like you don't want to enable that type of thing necessarily, right?
So we're also doing so much like a stress test for each the products which already exist in right now, and there's so many hallucinations and like so many harms, like to be honest. So like what we're doing right now is we're like working with the Boston Children's Hospital Digital Wellness Lab. So those lab is also like working closely with the big tech. So we are creating our own algorithm and our own using API, but like an own LLM to create this. But it's trying to kind of test and try what kind of like the algorithm and the tech behind, like not should be, but like it might be better to create in future for those big techs. So that's kind of like a co-working like research right now, but we don't have like any answers yet. But like in trying to kind of test and try like right now. Thank you.
Hi. First of all, very interesting presentation. Good research.
Thank you.
I wanted to ask you maybe two questions. First of all, have you tried looking, and if not, you can say no, from the epistemological lens of the knowing, coming to a knowledge, a lot of other things which oftentimes AI-based tutors normally skip because they are not trained oftentimes. So have you tried looking from that lens? Which is the epistemological reality of the child?
No.
Yeah, all right. Second is that there are ways, like nowadays, I think maybe, I'm not sure if you are already experimenting, there are ways through which you can do Socratic dialogue and really try, create guardrails where it doesn't give you answers at the first instance and really say, no, it will keep questioning you. It can get boring as well. I've tried it. But third and the most important point that I want to understand is the design. I often feel, and it's been experiment, I can give my evidence from my field work back in India, is that there is this entire addiction, which is the extractive part of the design of the tools itself, and how you are trying to look at those. I know you are saying that it has to be engaged, it has to be meaningful, it has to be socially interactive, but if you have to make it engaged, you also look into the design, and right now the design is very extractive in nature. I often hear people saying that, why don't you make an Instagram and people will learn? I said, how can someone learn in 20 seconds? But yeah, I want, maybe if you have not explored, but maybe your reflections on that.
So your question is?
On the design.
On the design? Yeah. You mentioned about, so how to make it more engagement, or like how like research is about that?
Today the design is itself saying, the engagement part is itself saying, okay, we will make it addictive.
Oh, okay.
Addictive
So what's the border of the addiction
addictive
and
versus something which is meaningfully designed, which says, oh, now you stop. You can also put a breaker and say stop, but is that the way to engage with the child? Is a question.
I think that's back to your question as well, but like it's still like working process right now. But
yeah,
like
you can stay with it. I mean, we can discuss it later, but this is the question that I have been kind of
No. It's a really important question, like addiction and engagement. But it's really important to show the limitation in the role. It's like a simple answer for you as well. Yeah. And like when it comes like a design system and like a UI, it's also like really that's like what we're like researching right now. So if you have any comments, like it would be great to talk with you afterwards.
Thank you.
Thank you.
Yes.
Okay.
Hello. Yeah. So you talked about your app, Irori, I believe.
Mm-hmm.
So you said that what the app could do was the teacher could record and talk about what happened, just short recordings, right?
Mm-hmm.
But obviously, we all know that AI isn't always right, AI hallucinations. So you mentioned the example of a child breaking down her Lego tower. So how do you make sure that the AI doesn't infer something wrong? So maybe the AI thinks that the child is just rageful, when in reality, the teacher couldn't deliver enough information to show that the child was actually trying to help her friend build another tower, so she broke her own tower apart. So like, how do you ensure that the AI infers correctly or doesn't make up its own predictions, or that the teachers deliver the right information? Because
Thank you. That's a really good question. So like the point is, I didn't show that, but like the every time like human in the loop process is really important in a whole like UI development, like app development. So what we are doing right now is, once the audio recordings happen, they're gonna text to the voice to text, so like the text is showing up. So the teachers are, before generating and analyzing everything, they can kind of like modify what they really like observing. And then after that, it's kind of like more like a core working process. So it's not like AI just generated you to, this is the result. So it's more like a really cool building. Okay, so that's what AI is thinking about based on the CDC milestones and all the evidences behind the researches. But what the teacher's perspective is more important, right? So those kind of like modification system is really important, and that's like a human in the loop system design is what we're really, really important to thinking about. So I didn't show it, but like that's like a really great question and perspective, and that's the part we are like also engaging in this app as well.
yeah, thank you.
Thank you. Great. Sorry. Thank you.
All right, so next we have Tanya Mishra, who's going to talk to us about the AI talent incubator that she started and leads called Sure Start.
You have audio? she does. I'm just going to make sure I am. Audio settings. Yeah, yeah. Entire screen. We didn't do a test, so we don't know how loud it's going to be. Is this Google? Should advance right here. Okay.
Good morning, everyone. Fantastic. It's on, and I am so delighted to be here with all of you at the summit to think about and start the discussion on how we can prepare our K-12 students for an AI-driven future. I'm really looking forward to the conversations we will have and the learning and sharing throughout the day and throughout the summit. Let me see if I can get to the next screen. All right. All right, so I am coming to this work and this conversation today from three perspectives. First, as the founder and CEO of SureStart, we are a New York City-based AI education organization with a mission to bring AI fluency to students around this country and around the world. And we've been doing this work for a little over 5 years, and luckily enough, with amazing collaborators and partners, among which the first was actually MIT. So it's very exciting to be here and talk to you about things we've learned. My second perspective is that of an AI scientist. I have worked in artificial intelligence R&D for 15 years before I started SureStart, and finally as a tech mentor that I have just been so privileged to mentor and support and advise emerging technologists, at this point probably many hundreds of them from around this country and around the world for my entire career. So I'm really coming to this conversation with all of these perspectives, as well as that of a parent with 3 children in middle school through high school. Okay, so let's jump in. AI is everywhere. It is in the apps we use, the services that we have really come to rely on, and in the hundreds, if not thousands of decisions that we are making each day with AI or through AI that have come to shape our lives. And among us all, our children, our youth, are its most enthusiastic users. So across multiple studies conducted in various countries, we already see that a majority of our youth are using AI for their learning, but also to manage the task of being a student, manage things that are around the act of being a student, the next steps that they are taking. So really the workflow of studentship, one can think of. More than 50% of them use AI for these purposes at least once a week, and 1 in 3 report using it daily. And I think these numbers are old because studies take a while to do, and these were all collected in the last 12 months, which means probably the numbers would be higher if we were to do the same surveys today. So looking at these numbers, you might say, well, if students are the most enthusiastic users, I think we've solved the problem. Well, but we know, and we've been hearing about it, with our 3 previous speakers, that usage is not the same as fluency. Usage might look like a student saying, hey ChatGPT, hey Claude, hey my favorite LLM, what is the answer to this problem? Can you generate this content? But fluency is so much more. Fluency means knowing when to use AI and when to not use AI. What are the appropriate tools for the various tasks? How do you verify the output of AI? What is shallow reasoning and what is well-reasoned output? And finally, and this is really important, how do you disclose it for formalized education? Because just like we teach our kids to cite our sources, our students also need to learn how to cite the use of AI, to understand when to, once again, when should they be including it in the work, in the learning that they are expected to do, and when should they not? And I just want to, as a parent to a high schooler who is currently taking a number of standardized tests, the interesting thing is that we've actually figured this out in many other domains. So if you look at ACTs, this standardized test that our high schoolers often have to take, there are parts of it in which calculator use is allowed, and there are parts of it when they're not allowed to use calculators. Students understand this, and teachers clearly make this known to them, but also when they are learning how to take these tests, it is very much part of the learning process. We need to do the same with AI so that AI use is not a hidden secret thing that our kids are engaging in, but this becomes a tool of agency, a tool of creativity, a tool that helps them bring their big ideas into the world. So how do we do this work? And so through the rest of this presentation, I'm going to just share a few approaches that we have seen work really well with our students. And as I said earlier, some of this work was done directly by my organization, Sure Start, and some of it was done with amazing, wonderful collaborators like MIT. So the first approach, start early. Let's start bringing AI fluency at the K-12 level. Let's not wait until college, because as we heard Hisako talk about, our children are surrounded by AI. They are using it multiple times a day and every day. What if we took a learning-first approach? So let's start early. This does not mean turning every middle school and high school student into an AI researcher or an engineer. It means exposing our students to age-appropriate AI education so that they can learn the underlying concepts of AI, they can learn how to effectively use contemporary AI tools, and they can start beginning to think about the impact of AI on themselves, on their friends, on the world around them. And this last, right, ethical considerations in the use of AI, like developing that ethical lens while they are developing their AI knowledge, that's what I call starting right. The next approach is to ensure that we are in our AI curriculum and our teaching methodology, the focus is not just on code, prompts, applications, but it goes beyond digital skills to continuously also engage their cognitive skills and the social skills. And if we look at research, it is actually predicted it's these last two, the cognitive skills and the social skills, that are going to continue to be really important in the AI era, especially if AI tools start to do all of the routine tasks. That actually leaves us and our youth more time to engage in the kind of exploratory, joyful activities that we heard Professor Sussman talk about, and the impactful activities that Evan talked about. And this third, I kind of alluded to it before, but this is the core of our approach in teaching kids about AI. That while kids are learning about AI models, AI data, predictions, generative AI tools, infused throughout that curriculum is ethical considerations in the use of AI. They're also learning about fairness, transparency, bias mitigation, accountability, and just broadly the human impact that AI is going to have all around the world. And it is not just a last slide or a last module in a long curriculum, so that we don't teach our kids that this is something that you think about at the very end. The fourth one is mentorship. Now, a little bit about our journey. From the very beginning, 5 years ago, when I started Sure Start, our focus has actually been all students, which means many of our students were coming into AI education with no prior technical knowledge and frankly a healthy dose of fear that AI education might not be for them. And this is where mentors have been absolutely transformational, right? When students are learning about this new field and they are learning it from near peer role models whom they can relate to, suddenly the learning becomes much more relational. There's a safe space in which our students can reimagine what they can learn about AI and more, what they can build with it. The fifth approach, and just as important, is that AI education must be inclusive. We must tap into the strengths of all learners, including our neurodiverse learners. And if you think about it, neurodiverse learners possess unique strengths that align very well with technical work, right? Being able, pattern recognition, systematizing skills, deep focus. So it's really high time that as we are thinking about upskilling and getting our young people ready for the future, we are making sure that we create pathways for our neurodiverse learners so that in the future, through career readiness, they have self-reliance and financial independence. And what has been beautiful but not surprising in our programs that we have developed for neurodiverse learners, that it has not only empowered the students who are in those programs, but it has actually helped us make our curriculum and our teaching methodology more robust and more generalizable, improving outcomes for all students. That's what inclusion does. And last, this is my very favorite approach. This is the approach that Evan talked about earlier. This is the approach that App Inventor makes possible. It is teaching students about AI through inquiry-led, project-based work. That means students are now empowered with new knowledge and new skills, new tools that they can apply to problems that are of their own choosing. And what is beautiful, that when students choose problems that are important to them, their family members, and their broader community, AI goes from being this dry technical subject that they are not so sure of and staying engaged is difficult, perhaps. It now becomes a tool of personal agency. And the outcomes that we have seen have been brilliant. We have seen high schoolers start a project that have gone on to raise funding to become a real company. Projects that are saving lives, projects that are improving the environment, projects that are winning national and international awards. So this is absolutely my favorite part. When we get to see what the students present, it's like seeing magic in action. I was going to play a video, but looks like it's not going to play. So find me later and I'll share the video. But let me say that through all of these different approaches, the primary learning outcome that we have in mind for our students is intellectual confidence. Confidence to explore unfamiliar ideas, to try out new projects, to ask bold, thoughtful questions like we heard some of our students today ask, and to build responsibly. Learning to learn is going to be a critical skill for our young people in the AI era, and frankly, for us as well. And this really brings me to the end of my presentation, and I want to leave us with an encouragement that the future is humans plus AI, not humans versus AI, coming together as we have today and working collaboratively. I am certain that we can prepare our youth to step into the AI future with skills, knowledge, and agency. Thank you so much for your attention. And I'm happy to answer some questions. Okay, I guess we have time for one question. Yes.
Hi, I really loved your presentation, especially the part about using AI and AI fluency. But I have a question on that. how do you make sure that when students are using AI, they don't get too dependent on it over time? Like, how do you prevent that from happening?
Yes, that's a great question, and very core to our approach is that in all of the projects that students have to build, they have to first develop the idea themselves. They have to go talk to lived experts who are experiencing that problem. They have to think about and research what has already been done and really identify the blue sky that their work is going to fill. And that's when they jump into prototyping, developing, building, and expanding.
Thank you.
Thank you, everyone. Let's continue the conversation.
I think your laptop needed to be on Wi-Fi.
All right, we have 2 more talks, then it's break time. I'd like to welcome up Kelly Shiohira of the App Inventor Foundation, where she's the Director of Impact and Community Engagement. For the foundation, she focuses on literacy, connecting education to the world of work, and responsible uses of AI and technology in education.
Is that you?
Nope.
Which one is it? Let's see.
Do you have Google Sheets?
Well, I downloaded all of
Oh, I think some of them were updated last night.
I know. That's what I've been finding.
I might have it.
If you want to use it. Okay, well.
Well, in the interest of time, because I know we're running quite late, while they do some technical work here in the background, maybe I'll just go ahead and start talking. That's okay. As Andrew said, my name is Kelly Shiohira. I'm the Director of Impact and Community at the App Inventor Foundation. And today I'm going to talk about something very near and dear to my heart, which is Africa. What we see, App Inventor is really built in order to enable all people everywhere to build apps that positively impact their lives and their communities. And one thing that we've been thinking about for about 10 years is how to better reach the poorest of the poor, frankly, the people who need it the most. And my own career and work has largely been in Africa and Southeast Asia. So with that said, you probably know some of the stats. There's increasing broadband reach in Africa. If you talk to the ITU, they will tell you that most people have access to a computer. But if you've lived there and worked there, you know that there are huge discrepancies in what that data actually says. It's calculated based on the number of SIM card sales. I lived in Africa for 6 years. I bought 15 SIMs over my lifetime there. So if you just look at the ratios, it's not a true representation. And then the second thing is that even after you get to that point of having access, Africa is one of the most expensive continents to connect to the internet, with affordability rates that are nowhere near the 2% GDP targets. So that said, we have established that Africa is one of the poorest continents. It's also one of the youngest continents. The average age in Africa is under 20. It's one of the most entrepreneurial continents, with 1 in 5 working-aged people engaged in new business, and 80% of labor in the informal market, which I would argue is an expression of entrepreneurship in itself. And we also know that Africa is extremely, what's happening here? Can I just hit continue? It does not like me. Perfect. So I wanted to show you this really excellent example of African entrepreneurship. The continent has unique problems, unique solutions, and amazing creative people who work on them. This is one team that won the coolest projects from Raspberry Pi. It's called Vim, which means power. And essentially, you can see there they've used lids from disposable cartons and some straws and some other things. They used MIT App Inventor, and they built this amazing device that can measure the best locations in their village to place solar and wind power devices to help them generate electricity, which is another major problem. So we see that there's a lot of examples. There's others. You might have heard of the soccer ball that generates electricity when you kick it and things like that. There's lots of great solutions on the continent. But we still see that there's a lot of challenges in reaching people and enabling them to start developing solutions like these. There is a video, but I'm not going to show it because we're so far behind time. Please look it up later. What we see with our global Appathon, particularly this year, is that while we have great participation from low-income and emerging markets, 69% of our participants come from countries that can be described as low-income or emerging. We see that the lowest income developing countries have a somewhat lower participation rate, around 11% of our participants, over 2,000 this year, by the way, were from low-income developing countries. And the completion rates for Africa and low-income developing countries are really poor. We only had 4 projects submitted from Africa this year, which is not a true representation of what the continent is capable of. So why is there this discrepancy between entrepreneurship and drive and creativity and what they can do? Well, it all comes back to the things I was saying in the beginning. Basic infrastructure is actually not as developed as some of the high-level statistics might imply. The cost is extremely high, so if you want to access or utilize these solutions that require data, you have to be in upper income brackets or have access to people who are or be part of a special program. And then all of that kind of builds onto a lack of human resources and the ability to drive these sorts of projects. It was really well put by this interview participant. Let's quote here, these things are stacking, right? If you don't have the base level infrastructure, if the costs are too high, then the developing of human resources is really difficult, and it leads to this kind of unvirtuous cycle, if we could say that. So what do we do about that? We finally got some good partnership with the World Bank this year and developed a prototype called AI in a Suitcase. And the idea behind AI in a Suitcase is that it's an offline solution that leverages the block-based coding of MIT App Inventor and can enable these communities to finally work with technology in ways that meet them where they are, both in terms of the technology they have access to, maybe outdated devices, right? Maybe older smartphones, if any at all. Company donations are big, so it's kind of cast off tech that they work with. So we developed a prototype that accommodates that leverages the lower resources needed for blocks-based coding, and that is low cost, which is really important, and low energy as possible. It will run on a Raspberry Pi 5, although that is not what they did the pilot on, but I'll let the tech team tell you all about that. So the last point I wanted to make about this is that while we do have a prototype, we're really looking for partnerships. We want to pilot it, we want to expand it, we want to see if the solution can really work in Africa, and not just Africa. If you look at the quote here, some teachers have to drive an hour and a half to get to an internet point. You might think that comes from Africa, but actually that was someone from Australia. We had other people in Germany tell us that they have similar constraints. So although I have talked a lot about Africa, and I mentioned I'm quite passionate about it, this solution can also help in other contexts to reach this final tiny piece in some of the more developed countries that still don't have the access that they need. And also, I mean, another use case that I'd just like to point out based on our conversations here this morning is that schools are starting to push back against cloud technologies and privacy and deal more with and think more about how they can protect their learners. And so offline solutions like this that don't upload to the cloud and are very respectful of privacy and self-sovereign identity would be a solution that could be used in that context as well. So long story short, we're looking for partners. If you'd like to collaborate with us on this project, we would love to have you. And I'm around. Thank you. Do we have time for questions, or you can find me later? Yeah, there's a prototype here as well, so if you want to check it out, we can do that too.
Yes, but we can skip it for time. Yeah. Okay. Oh, sorry. Just let it load for a minute. Okay. Yeah, hello everyone. I'll try to make this quick. My name is Annabelle Tiong, and I'm the co-director of MIT Hacking Medicine. And MIT Hacking Medicine is an organization we've been running for nearly 20 years now. And what we do is we host medical hackathons. So how many of you have ever participated in a medical hackathon before? Just curious. How about a hackathon in general? Okay, yeah, that's what I was thinking. So we're a little non-traditional in the sense that this isn't the hackathon you would expect, where you're coding all night, you're with your team, not sleeping at all, kind of just camping out and trying to really build out your solution. What we focus on is the pitch, and specifically the pitch in medicine. So as I'm sure many of you can probably expect, a lot of the people that we work with are doctors, clinicians, nurses, nurse practitioners, people who might not have that traditional coding background that I'm sure many of you have. And so instead, what we want to focus on is the innovation. So yeah, we have a quick video about what we do, but maybe for the sake of time, we can just skip it. Yeah. So no worries, but I'll just talk a little bit about what it is that we try to do. So we've hosted over 200 hackathons in 30 different countries. Our most recent one was in Paris. That was fun, learning about the French healthcare system. But essentially, our goal is to really democratize healthcare and make it a space where ideas are open to anyone. So our goal is really to promote this design methodology where we bring together participants from diverse backgrounds, whether they come from an engineering background, whether they're a student, or whether they actually practice medicine, and bring them together to come up with solutions that can transform healthcare. Our methodology has been published in several different research articles, and it's unique because it pushes this cross-disciplinary approach, where you don't just focus traditionally on the hacking of the solution rather, but pitching the problems and going through a design thinking process to approach healthcare as a system. You might have heard of some of the companies that have actually spun out of our hackathons. I think the most famous being PillPack, which was recently acquired by Amazon, but also Podometrics, Overjet, Rubicon MD. All of these were actually had their origin at one of our MIT Hacking Medicine events. So this is the process for a hackathon. We're going to be running one here actually, and it'll be very compressed and sped up. So, but generally what happens is participants get the chance to meet their co-founder, where they get to pitch problems that excite them, and depending on what problems that others are also passionate about, they're able to talk with others who have a similar interest to them and form teams around that problem. Then over the course of the weekend or however long the timeline of the hackathon is, they'll iterate on those problems and get feedback from mentors. Then they'll pitch to the judges, and typically there's an award ceremony or some sort of follow-up. And so we'll be running the problem pitching session this afternoon at 3:30 p.m. So if you're interested in participating in the hackathon, we would love for you to come out. So just some guidelines about what it is exactly that you should be doing at one of these hackathons. For sure, open yourself to any idea that gets pitched out there. Maybe you come in with a certain problem, like, oh, I really want to work on an app for Alzheimer's disease. But you hear this amazing pitch about Parkinson's that you never would have expected yourself to be interested in Parkinson's. You have no clue, any background about Parkinson's, but this is just something that catches your interest. So we find that the most successful teams are the ones that are able to change and pivot their ideas on the spot, but also fail fast and not be afraid to get back up fast. Also, we really want you to focus on building something, anything. It doesn't have to be fully fleshed out. It doesn't have to be working necessarily, but just having anything to get your ideas out there is really great. So for don'ts, don't know how applicable these are in this setting, but again, you don't need to worry too much about patenting, ownership. Don't be shy, anything like that. The goal of this is to really just have fun and to meet people who you might not have envisioned yourself working with. So the principles for our solutions are typically that they meet a real need, that they're based on a good story, they can be scaled, iterated, and tested. And these are the criteria that we use for judging. So we care about the impact. Does your problem have widespread impact? And does your solution actually address that problem? We care about the innovation. So why will your solution work? Why is it different from traditionally existing solutions that are already in the market? And are you taking into consideration how your users are going to use this from the beginning to the end of your product? And are you taking into consideration how your design is actually tailored to those users? Also, another thing that we have that is very unique about our hackathons is that we attract a lot of business students or people with a business or entrepreneurial background. And as a result, the startups that come out of our hackathons have been very successful doing market research and being able to actually break into the market. So it's great if you can have some sort of sustainable business model for how your product might actually get deployed in the market. And then, of course, it doesn't matter how great your solution is if you can't effectively convince your judges that your solution is great. So making sure that you're able to convey your ideas effectively and show that you're passionate about your solution that you came up with. So for problem pitching, it'll happen this afternoon at 3:30 p.m. to kick off our hackathon. And essentially, you'll have 45 seconds. We'll invite people to come up to the stage, and you'll just talk about a problem that you want to address. Again, it doesn't have to be fully fleshed out. You can just come up here and say, my mom has been struggling with taking her meds and hasn't been able to remember which one of her meds to take, so that's a real problem. And that's actually the problem pitch that founded PillPack. So yeah, I just want to encourage everyone to participate in the hackathon if you're interested, and really looking forward to working with everyone this afternoon.